Okay, everyone, we're working on shapes today, both 2D and 3D shapes. So we're doing area, perimeter, volume, and then surface area. And we're going to talk about some of the shapes too. So polygons, that's what we call the shapes. The official name. It's a closed figure formed by a finite number of coplanar segments called sides. So, technical definition of a polygon. The sides have a common endpoint. They're all non-collinear, and they intersect exactly two other sides, but only at their endpoints. In general, polygons are classified by its number of sides. We basically know squares, rectangles, things like that, but what we're talking about here, it's like quadrilaterals and pentagons and hexagons and octagons and dodecagons, things like that is what they're talking about. The vertex of a polygon, that's where each angle where the sides intersect. And then the polygons, when we name them, we're naming them by the letters of their vertices, written in consecutive order, consecutive vertices, basically from in a clockwise rotation. So if you see a shape, you pretty much go around it clockwise, starting in the top left corner and going around. Polygons can be concave or convex. So when you think of it, it's like imagining you're drawing lines for either side of the polygon. What we're looking to do is figure out what the shapes are. So what we're going to do is a concave polygon. Whoops, wrong way. Sorry about that. A concave polygon will have some of the points of the extended lines are inside the polygon. So if we look at the shape on the left, what you do to check them out is you kind of extend all the lines. We can extend the line that way. We kind of go through this way. We'll go this way rather than just having the sides end. We're going to draw the line on the way out. So we have that one. We'll do the same thing here. So I've extended the lines, and what they mean by a convex or concave polygon is they say that it doesn't have any parts of the lines inside the shape. Or the concave, does have lines, parts of the line shape. So when we look, we have like the lines extended, they kind of cover there. So those are inside the shape. So that makes the one on the right a concave polygon. The convex polygons, those are the ones when you extend the lines never cross inside the shape, or they never go into the shape. So the shape is kind of what we call clear. And that is the definition. Convex polygon will have no points of the extended lines inside the shape of the polygon. And then we have an equilateral polygon has congruent sides, and then an equiangular polygon has congruent angles. We also talk about a regular polygon, and that's the polygon that it's a convex polygon that has both equilateral and equiangular. So all the sides are the same measurement, all the angles are the same measurement. The easiest one to think of is a square. All the four sides of the square are the same. All the angles of the square are 90-degree angles. Here are some of the more common names of polygons what we work with. The triangle, quadrilateral, pentagon, hexagon, octagon, decagon, dodecagon, and then the last one's a nonagon. We'll kind of deal with that a little bit later on when we get to determining the interior measurements of angles and things like that, but that's a unit down the road. Okay, perimeter. The distance around the outside of the polygon. We knew that, obviously. It's calculated by adding the measurements of each side of the polygon together. Circumference, that's the distance around the outside of a circle. I like to talk about it as the perimeter of the circle. They just use a different name. Again, that's calculated by multiplying the diameter, which is the distance across the circle, by pi. And then the last one, area, we all know it's the space occupied by a two-dimensional shape on a plane. This calculation now is going to depend on which type of shape we're talking about as we go through these. So here's a general breakdown of the shapes. We have triangles, squares, rectangles, and circles, and then what the formulas are for each each shape. And then these ones here were circumference, square, rectangle. We don't care about their circumference. And then always remember when we're talking about triangles is the height of a triangle is going to form a right angle with the base. You'll actually learn about that next unit as well. The definitive answer of why that is. All right, so we have some examples. We have a triangle. We're trying to find the base. We're going to call this a right angle, so I know what my area is. My area of a triangle is 1/2 the base times the height. I have 1/2 times 3 times 4, which I know is 6. So my area of this triangle is 6 inches, and then don't forget the squared because it's the area. Perimeter is just the sides added together, so 3 plus 4 plus 5 equals 7. Second one is our rectangle. The perimeter of a rectangle is 2w times 2l, or plus 2l, 2w plus 2l. So my width is 2 times 2. My length is plus 2 times 3. So I end up with 4 plus 6. So my perimeter here is 10. Area we know, or 10 feet, sorry. Area is just width times the length. So my area is going to be 2 times 3, or 6 feet squared. And then the radius of the circles, my circumference I know is either 2 pi r or pi d, depending on what you're given. We're given radius, so we're going to use the 2 pi r. So it's 2 pi times 5 or 10 pi. What we're going to do in this unit is not worry about multiplying pi, especially for the test, is I'm not going to have you worry about multiplying some random estimate of what pi is. Everybody knows pi is a never-ending decimal. We can estimate it to be 3.14. What I'm just going to have you do is leave your answers in terms of pi. So 10 pi is sufficient for the circumference of the circle. The area of the circle is pi r squared here. So my area is going to be 5 squared times pi, which is 25 pi. Again, we just leave it in pi, in terms of pi, and that'd be inches squared. Does that make sense to everyone? Okay. Here are 3 that I want you to try. Perimeter and area of the shapes. Enter your answers in an Edpuzzle, and then come back and check and see how you did. Whoops, went too far on my slide. That didn't work out. Sorry about that. Oh, I see what happened. So you got the picture. You understand what happened there. Sorry about all that. Let's move on. Sorry about all that. Solving for perimeter on a coordinate grid. Here you're going to have to use the distance formula, which we learned last unit. Hopefully you remember it. Figure out the perimeter and the area of that shape. If you don't remember the distance formula, I'll tell you the shape's a square, so we only have to figure out the distance once. The distance formula was the square root of x2 minus x1 squared plus y2 minus y1 squared. That's how you find the distance. So you'd have to find the distance between 2 of the points. It's all the same for each side. Then figure out the area and the perimeter. Enter the answer in Edpuzzle and come back and check how you did. Oops, sorry. So here we are. Perimeter should have been 16 square roots of 2. Again, the distance worked out. We had to simplify that down to 4 square roots 2. The area then is 4 square roots 2 squared. Remember, when we square a square root, it becomes that number. So it's 4 squared times 2, or again, 32. Does that make sense to everyone? Okay. Another one for your turn. Here is a triangle, again on the graph. If you remember the distance formula for the last side, use it again. There is another way to find out the distance of the long side for the perimeter. That's the only calculation you're going to have to figure out is the perimeter from A to B for perimeter, A to C for perimeter. You should be able to find an easy way to figure out the other areas, or the other distances you need. All right, so here's the answer. I just counted down from A to B for my height. I counted across from B to C for my base. I used that as my area, my base times my height. I found my area was 24. I used the Pythagorean theorem to find C, so it's 8 squared plus 6 squared equals 100. So C squared equaled 10. So then my perimeter became 24 as well. Does everybody get that? Okay. Three-dimensional figures. A solid is a solid with a flat surface that encloses a single region of space is called a polyhedron. Each flat surface or face of that polyhedron is a polygon. The line segments where these faces intersect are called edges, and the point where three or more edges meet is called a vertex. Think of a cube. Think of a dice. A dice is a solid. It encompasses all the area inside that dice. That's what they're talking about. Polyhedrons or polyhedra are named based on the shapes of their bases. So you could have a cube, or you could have a six-sided prism, so it would be a hexagonal prism. Those are the differences. You can have prisms and you can have pyramids, is what we're talking about. Prism is a congruent parallel polygonal face connected by parallelogram faces. So think of a cube again. A pyramid has a polygon base and then three or more triangular faces that meet at a common vertex. Think of the pyramids in Egypt. First question from the Kahoot the other day. The other three solids that we know of is a sphere, which is basically just a ball. There's also a cylinder, which is a circular base, but then it's connected by what works out to be a rectangular, typically a rectangular surface for the sides. And then the other one is a cone, which is similar to a pyramid, but it is a circular base connected by a curved surface, which is kind of harder to describe. And then they're not polyhedrons. Polyhedrons are only the polygonal ones. Here are some common, what they call regular polyhedrons. They have the sides and the bases, or all five of the sides are the same. They're regular congruent polygons. So a cube is 6 squares combined together. An equilateral, a tetrahedron is 4 equilateral triangles are the faces. An octahedron is 8 equilateral triangles. Then you kind of get into a couple of the other ones. A dodecahedron is 12 regular pentagons all combined together. And then icosahedron is 20 equilateral triangles that are all joined together. We do not work with these at all. We only really deal with the cube. We don't worry about any of the other sides. Don't worry about that. Surface area and volume. Surface area is the two-dimensional measurement of the surface of a solid figure. It's the sum of all the areas of the faces. So you find the area of each side of the solid figure, add them all together, that's the surface area. Think of it as you have a tissue box and you unfolded the tissue box, you cut all the sides and unfolded that, it's just the area of that. The volume is the measure of the amount of space enclosed by the figure. And on the next page, we're going to see it's the formulas for surface area and volume with the shapes that we talk about. Again, these will be provided for you on the test. You also will have them in your notes as it's an open note test. Okay, so examples. The surface area of this pyramid is the area of the base, which I will put as 24 times 24, plus, and then what I'm going to call it is 4 times, because it's a square on the bottom. So it's 4 times the area of my face. Well, my face is, the height of my face is this 13 centimeters. So it's going to be 1/2, whoops, not 1/3, it is 1/2 13 times 24. Does that make sense? Because I have 4 faces of the pyramid. So I know this here is 576 plus 4 times 1/2 of 24 is 12. So 12 times 13 is 132. So 4 times that. So 2 times 132 is 264, and 2 times that is 528. So my surface area is adding those two together. So I end up with 1,004 centimeters squared. That's my surface area. The volume then is just the area of the base times the height. My area of the base again was 576. Actually, the volume, sorry, is 1/3 the area of the base. So big B times my height. I've already figured out that the area of the base was 576. My height is 5. So volume will be 1/3 of that, which is going to be, actually, let me grab my calculator really quickly. Poor planning on my part, not knowing what the answer is. It works out to 576 times 5 divided by 3 is 960. So it's 960 centimeters cubed. Does that make sense? Okay. Cube, surface area of the cube is all the faces added together. So what I'm going to do is I'm going to kind of cheat a little bit. My base here is 5 times 2. I have two bases. I have the bottom and the top as my 5 times 2. So my surface area is going to be 5 times 2 plus what I'm going to call my perimeter. So it's 2 times my base. So it's my perimeter times my height. So the perimeter of my base is 5 plus 5, and 2 plus 2 is 14. So the surface area here is going to be 2 times 10 plus 14 times my height, which is 6. Did everybody see that? I just took the area because that's going to give me the sides of my bases. I'd have to do 5 times 6 twice, front and back. I'd have to do 2 times 6 twice, side to side. So I just add those up together. So my perimeter is 14, multiplied by my height, that gives me the area of all those sides. So this becomes 20 plus 84. So the surface area here is 104 inches. And then the volume of that we know is just 5 times 2 times 6, which is 60 inches cubed. Surface area of a cylinder equals 2 times big B for the area of the base plus the circumference times the height. So my area of my base is pi r squared. So radius is 2, so that's 4 squared, or 4 times pi, so 4 pi. I have 2 of those, so that's going to be 8 pi plus the circumference of my base is 4 across, so that's 4 pi times 6 is 24 pi. So the surface area here equals 32 pi feet. And again, the volume is just the area of the base, which I've already figured out. One base is 4 pi, so volume equals 4 pi times my height, which is 6, so it's 4 pi times 6, or 24 pi is the volume. Does that make sense to everyone? Okay. Here's 4 for you to try. Give them a shot. See how you do. Enter your answers in Edpuzzle, and then come back and check your work. Don't worry if you mess up the cone. The cone was actually kind of difficult for me to do as well, and I really didn't like the question after I did it. All right, so here are your answers. The surface area of the cube is 192 inches. The volume is 160 inches cubed. Everything's highlighted. Volume of the triangular prism is 30 meters cubed. The surface area is 72 meters squared. And then the surface area of the cone was 2 times pi times the radius times L, which is the lateral face height, which you would have had to figure out yourself by the Pythagorean theorem, creating a squared plus b squared with the height and the radius of the base. When we work all that out, the L actually works out to be the square root of 5. So the surface area is 2 times pi times 1. Times the square root of 5 plus the area of the base, which is just pi. So the surface area actually works out to be 2 square roots of 5 pi plus pi. Said that was a terrible question. The volume is just 1/3 the area, 1/3 the area of the base times the height. So the area of the base again was 1 pi times 2 for my height. So it really works out to be just 2/3 pi. So that's surface area and volume and all that stuff. There'll be a little bit of a section on the test for this. Again, you will have all the formulas on the test. There is homework on the classroom. Again, leave your answers in terms of pi if it's a circle. But there will be some decimals on that homework too. So good luck with that, and I will talk to everybody on Monday.